All right, guys, here it is, the last lesson of e-learning, and then we're done. So we skipped 10.3, so that's why it says 10.4 here, just to kind of save us a little bit of time. And so what we're going to talk about today is the addition rule, which is called mutually exclusive versus inclusive events. My son said, yeah, I talk about it. I know you just learned how to do addition, didn't you? All right. And so we're going to look at some of the keywords again that you want to look for, because now it's kind of up to you guys on whether or not you multiply or add to figure out the actual probability of different events happening. All right, so if we look just at here, this first. Okay, so it says when rolling a 6-sided die, what's the probability of rolling an even number? All right, well, there's 3 out of 6 even numbers, so that would be 1/2. So there's a 50% chance you'd roll an even number. Okay. What's the probability of rolling an odd number? And there's 3 out of 6 odd numbers, so that's also going to be 1/2. All right, so now we get to kind of the intro to what we're going to be looking at here. This now says, what is the probability of rolling an even or an odd? So I can roll it, and I want to know the probability that the number is going to be either even or odd. Well, every single number on the dice is either even or odd, so that would be 100%. There's a 100% chance. And again, to get that, I said, well, there's 3 evens, there's 3 odds. So that's 6 out of 6, which is 1. So we added those two probabilities together. Okay, so now what's the probability of rolling a prime number? All right, so the prime numbers are 2, 3, and 5, right? 1 is actually not a prime number. 1 isn't necessarily classified as prime or composite. So there is a 3 in 6 chance. There's 3 primes. So that again would be 1/2. Now this is what is the probability of rolling an even or a prime number? So if I list out all 6 numbers, 1 through 6 here. So if I want to know the probability that I roll an even, so there's 1, 2, 3 evens. So there's 3 out of 6 that are even. And then if I circle the prime numbers, I'd circle 2, 3, and 5. So there's also 3 prime numbers. But I circled that 2 twice, so there's an overlap. You can't count that twice. You can't count that for a prime and an even number. So we have to take away that one value that overlapped. And so that would be 5 out of 6. Okay, so that is the difference between independent and dependent events versus mutually inclusive and exclusive events. If you look at the language here, this is saying what's the probability of rolling an even or a prime number. So you're just talking about one roll. If I changed this to what's the probability that I roll an even then a prime number, that's 2 rolls. So that's when we would multiply the probability of 2 separate events. So the key word that you want to look for when determining whether it's dependent or independent or inclusive or exclusive is the word or. That signifies one event or one roll. Then, and, things like that. That's 2 different events. So that would be multiplying. Okay, so if 2 things are mutually exclusive, that means that 2 outcomes do not overlap. All right, so that would be like this example here. There's no evens that are also odds. or vice versa, so we don't have to subtract everything. So the probability that A or B happens is the probability of A plus the probability of B. That would give you the probability that either one of those things happen. But if two events are mutually inclusive, that means that two outcomes have an overlap. Okay, so I just think of that word like included, right? If you are looking at something where you have a value that's included in both probabilities, those would be mutually inclusive. Okay, so what you have to do when you find the probability is find what that overlap is. Is it one outcome, two outcome, three outcomes, etc.? But you always take the probability of each and then subtract the overlap. Okay, and so when we look at these examples here, if I have a deck of cards, I want to know the probability that I pick a red face card or a spade. Okay. All right, and so if I think about whether these are inclusive or exclusive, well, if you know anything about cards, which I will post like a graphic with a deck of cards, so if you need it while you're working on either your quiz or your homework, you have that there. There are 52 cards in a deck. Okay. Broken up into 4 suits. So 13 hearts, 13 diamonds, 13 spades, and 13 clubs. Okay. These are red. These are black. And so then there's like 4 2s, 4 3s, all the way through kings. So if I want to know the probability that I pick a red face card, okay, so there would be 2 jacks, 2 queens, 2 kings. Those are the face cards. So there's 6 hearts and 6 diamonds. That would be red face cards. So then 6 plus 6 would be, oh, I'm sorry, I misspoke. That would be the total. There's 2 red jacks, 2 red queens, 2 red kings. So the probability of that would be 6 out of 52. And then there are 13 spades out of 52. There's not going to be an overlap because since spades are black, you're not going to have any red face cards in that black suit. Now, when we multiplied the other day, I mentioned that it might be more helpful to simplify your fractions first to keep those denominators down. However, remember when you add fractions, you need to have the same denominator. So you actually do not want to simplify, or else you're going to have to just multiply it back out to get the denominators the same. So when I add those together, that's going to give me 19 out of 52. So there are 19 out of 52 cards that are either a red face card or a spade. And so that would be my probability, which is about 36.5%. So these are exclusive events. Okay, and again, whenever you see that word or, that kind of represents just like one draw. So if I pick one card, what are the chances that that card is either a face card or a spade? If I said, what's the probability that I pick a red face card, then a spade, that's 2 draws, that means you multiply. Okay, all right, so if we look at this next one then, find the probability that I pick a jack or a heart. Okay, well, there's 1 jack of every suit. So there's 4 jacks out of 52 cards. There are 13 hearts out of 52 cards. So then I want to think, is there a heart that's also a jack? The answer is yes. So I can't count that twice. I have to subtract that 1 out. Okay. So these would be inclusive events. So 17 minus 1 would be 16 out of 52. We'll simplify that fraction. See, if I divide both by 4, that would be 4 out of 13. And then as a percent, that would be about 30.8%. Okay. All right, and so now we get back to the dice. So this one says, find the probability that I roll an even or a multiple of 3. So again, that's just one roll. What's the probability that that number is either even or a multiple of 3? Well, we've said that there are 3 evens, so 3 out of 6. The multiples of 3 are 3 and 6. And so that would be 2 out of 6. But if we list everything out down here again, my evens were 2, 4, and 6. My multiples of 6 were 3 and 6. So that 6 was counted twice, so we have to make sure we subtract that out. And so when I do 3 plus 2 minus 1, I get 4 out of 6, which is 2/3, or 66.7%. Okay. And now rolling a 2 or an odd number. So again, this would be inclusive because there was an overlap. Well, if I think, are there any odd numbers that are 2s? No. So these are going to be exclusive, which means I'm not going to have to subtract anything. So there's a 1 in 6 chance that I would roll a 2. There's a 3 in 6 chance that I roll a number. And again, there's no overlap there. So this is also going to be 4 out of 6, which is 2/3 or 66.7%. So again, I will repeat. You add when it's one event, one draw, one roll, something like that. You multiply if you're looking at 2 separate events. Okay? All right. Keep on going here. So this next example says a bag of M&Ms contains 7 yellow, 7 red, 7 brown, 9 blue, 9 green, 10 orange. So first let's find the total here. So 7 plus 7 plus 7 plus 9 plus 9 plus 10 is 49. So there's 49 M&Ms. I want to know the probability that I choose either red or green. Okay, well, I can't pick a green M&M that's also red or vice versa. So that means that these are exclusive. There's not going to be an overlap. So I have... what am I looking at again, red or green? All right, so I've got 7 out of 49 M&Ms that are red. I've got 9 out of 49 M&Ms that are green. And I don't have to subtract anything because I'm just looking at one draw. So in the bag, I have a total of 49 M&Ms. 7 are reds, 9 are green. So that means that I have a 16 in 49 chance that my M&M is going to be one of those colors. So that would be 32.7%. Next question says, in a certain game, a player rolls a die and draws 1 card out of a standard deck of cards. What is the probability that they roll a 5 or draw a diamond? Again, these are 2 completely different things. I'm looking at a dice and a diamond. So no overlap's going to happen here. There's a 1 in 6 chance that I roll a 5. There is a 13 in 52 chance that I draw a diamond. Well, we have to add these fractions together. So one way you can do it is kind of the long way, or just type it in, right? 1/6 plus 13 out of 52. If you want to do it by hand, you'll need to make sure you get the denominators the same. And then I'm just going to go ahead and leave this as a percent. So that's going to be about 41.7%. So if you're ever taking like an SAT or something like that where time is an issue, instead of, so let's say all 4 of your choices are fractions, right? So instead of getting common denominators, adding them together, if you're kind of quick at doing that, then that's one thing. But the other thing you can do is just what I did, and then look at your answers and just type them in and figure out which one ends up being the same percent. Okay. All right. Next one. At a school of 1,400 students, 550 take Spanish, 700 take biology, and 400 take both. So here's like our overlap here. What is the probability that a student selected at random takes Spanish or biology? Well, this is already going to be inclusive because we're essentially given that here, right? We know that 400 overlap. So if I want to know the probability that one of these students takes one of these classes, I would take that 550 plus 700 and then subtract the 400 that take both. Now the denominator in all 3 of these is going to be 1,400, so I'm just going to go ahead and put that all under 1,400. So 550 plus 700 minus 400 is 850 out of 1,400. So if you want to practice simplifying that, you divide both by 25. See if that gets me down enough. Guess I could have gone 50, but I'll have to do that again. 56. And then both of these are going to be divisible by 2. So 28 in the denominator, so 17 out of 28 is 60.7%. Okay. All right, next one. What is the probability of drawing a king or a heart from a standard deck of cards? All right, so again, king, this is kind of like this jack and heart one right here. There's 4 kings out of 52. There are 13 hearts out of 52. One of those hearts is also a king, so we need to subtract that. 17 minus 1 is going to be 16. We already did that because this was basically the exact same problem, just a jack. So that's going to be 4 out of 13, which is 30.8%. All right, and then last question here. In my 3rd period class, there are 36 students, 19 males and 17 females. 7 males play soccer, 4 females play soccer. What is the probability that when selecting a student at random, the student will be a female or a soccer player? So again, I'm only picking one person one time, means you add. If I said the probability that I pick a female and then pick a soccer player, that's 2 draws, multiply. Okay, so females, there are 17 out of 36. Soccer players, there are 7 plus 4, which would be 11. And then I have to consider the overlap. So if I'm looking at female soccer players, there's 4 of them. That would be my overlap. So here's really the first one, I think. Oh no, this one, we subtracted something other than 1. So you're not just always subtracting 1. It's however many overlap. So 17 plus 11 minus 4 would be 24 out of 36. Divide by 12, you get 2/3 or 66.7%. Okay. All right, so your homework tonight, there's a little bit more of this lesson on there than the other two, just for some extra practice. But tomorrow we will end with a little, like, call it a quest, I guess. It will go in the test category, but just out of 50 instead of 100, like the other two tests from this trimester. And so it will be a little bit like heavier than the other quizzes that you've taken, but since this is the only assessment, that's just how we decided to do it. So tonight's assignment is a review over all three. I will post a little bit more practice before you take the quest tomorrow if you want it. That'll be optional, but if you have any questions, you can also reach out to me. Have a great day, guys.